High-performance cars typically have ceramic composite brake discs rather than regular cast iron ones. That kind of power on wheels requires being lightweight, and cast iron is very heavy. It would also wear out too quickly due to the intense heat friction generates when you brake a car with such a powerful engine. Ceramic is heat-resistant, up to 1830 degrees Fahrenheit. Therefore, these ceramic composite brake discs last about 60 times longer than standard cast iron discs. Ceramic composite means the ceramic material, silicon, is combined with carbon fiber for strength. The disc factory prepares the carbon fiber by mixing two ingredients, a heat-molded resin and chopped pieces of raw carbon fiber, the strength of which lies in the interweaving of its minuscule carbon filaments. Automated machines pour the carbon fiber into aluminum molds in the shape of the disc ring. The first filling station fills the mold cavity only halfway. Workers then fit a slotted belt around the mold and insert aluminum cores into the slots. These cores will form a ventilation channel in the disc ring to keep the disc from overheating. Now the mold moves on to the next filling station. It fills the remainder of the cavity with carbon fiber. A roller levels the top. Then workers close up the mold and a small press pushes down the cover to lightly compact the contents. The mold enters a large press which applies 20 tons of pressure while heating to almost 400 degrees Fahrenheit. This compacts the carbon fiber and transforms the resin powder into plastic. Once the mold is cooled down enough to be handled, workers submerge it in cold water for 5 to 8 minutes. This cools the disc ring completely, enabling them to pull out the cores. A computer-guided laser then examines the mold to make sure every last core has been removed. When they get the all clear, they open the top and bottom sections of the mold and extract the disc ring. Computer-guided machines then smooth out the rough areas and drill tiny ventilation holes. They put the disc ring into an oven, which over the course of 2 days, gradually heats it to just over 1800 degrees Fahrenheit. This causes a chemical change, which transforms the plastic into carbon. Next, they take a crucible, a high heat-resistant container, and position 5 mounts inside. They place the disc ring on the mounts. Then in the middle, a funnel, into which they pour a ceramic material, a fine silicon powder. Then they load the crucible into an oven for 24 hours. It gradually heats the disc ring to more than 3000 degrees Fahrenheit, melting the silicon. Then it applies low-level suction, drawing the now liquid silicon into the disc ring. This creates an exceptionally hard new material called silicon carbide. After a computer-guided drill bores mounting holes, the disc ring goes into a chamber where it receives a coat of protective paint. The paint shields the carbon in the disc ring from oxygen, which is critical because at high heat, oxygen burns carbon. This anti-oxidation treatment significantly extends the life of the brake disc. The paint is cured in an oven, leaving behind a white residue. A robot sands it off, then polishes the entire disc ring surface. Here's what the finished disc ring looks like before it's cleaned and polished. And after. Every single brake disc ring undergoes a meticulous inspection. This sophisticated machine takes thousands of high-definition photographs of the surface, which a computer then analyzes in micron-level detail. To complete the brake disc, they affix the bell, a circular component in the middle which connects the brake disc to the vehicle. The bell is made of either aluminum or stainless steel and bolted into the mounting holes in the disc ring. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/how it's made.